Baik. Ingatkan saya sekiranya kalau Zoom 40 minit dah putus, saya terlupa rekod ya. Baik, hari ini kita akan lihat soalan-soalan yang awak telah buat bagi circular motion. Baik, kita tengok lesson 15. Okay. So lesson 15. So worksheet for lesson circular motion 1. So an object move in a circular path with a constant speed. State whether its speed, velocity, angular velocity, linear momentum. Okay, linear momentum tak payah. Okay, linear momentum tak ada dalam syllabus awak. Okay, sekarang dah tak ada. Tetapi dalam jangkaan untuk murid tahun depan, linear momentum, angular momentum akan masuk kembali. Okay, so ini tak payah. Okay, varying or remain constant. Okay, which one will remain constant? Okay, remain constant, speed constant. Velocity, that means that varying. Okay, angular velocity, how is it angular velocity? Angular velocity. So this one is constant. Okay, angular velocity is constant, speed is constant, just the velocity will change. Why it changed? Because change of direction. So to state the condition that enable the object to continue its circular motion. Okay, so what is that? So that means that the condition that enable the object to continue in circular motion, that is the centripetal force. So this means always, okay, acted by a centripetal force. So this means that with the centripetal force, this object will always remain in circular motion. Question number 2, name the centripetal force for the following circular motion. A pendulum that moves in horizontal circle. Okay, if the pendulum is moved in the circular motion, okay, it swing in the circular motion, so the centripetal force, that means that this is the string, this move with the motion like that. That means that the centripetal force always point to the center, that is the tension. Okay, the tension of string. Next, the Earth revolves around the sun. Revolve around the sun. That means that, okay, if this is the sun, this is the Earth. Okay, for next chapter, okay, gravitation, we will learn about that. So that means that there will be a F. What is the F? That will be the gravity. Okay, so gravitational force. So that is because of the gravity. And last, a car. Okay, a car is negotiating turn. That means that a car is moving without skipping, without lost control. So this means that yesterday we learned that that is the friction. Friction between the tire and the rod cause a centripetal force which always point to the center of the circle. Okay, next we go to the next question. Three, an object performs circular motion with radius r and linear speed of v. What is the angular speed in terms of r and v? So this means omega equal to v over r, or v equal to r omega. So once we write like that, we must write out omega equal to angular velocity. V is equal to the, what is that? So linear velocity. So r will be equal to the radius. So that's all. And next, what is the angular acceleration? Okay, if the object perform a circular motion, that means that the v will be constant, right? So how about the angular acceleration? The object now, an object is moving in circle. Okay, with the angular speed is equal to constant, right? Velocity varying, change. Why? Because change of the direction. Okay, so from here, this one, if the angular speed is constant, that means that the angular acceleration will be equal to, is it any change of the angular velocity? No, right? There is no change of the angular velocity. That means that it will be no angular change of the acceleration. So that means that angular acceleration is equal to 0. Okay, so that means none speed, because the, what's that? Because the what's that? The angular velocity is constant. Okay, get it? Now let's go to the next question. Question for the worksheet on lesson 16, circular motion 2. 1. Okay. Okay, calculate the angular speed. Calculation now. Calculate the angular speed of the second hand of a clock. So second hand of a clock, second. Okay, jarum yang menunjukkan saat. Jarum saat. So second hand of a clock. 1 revolution is equal to how much? Okay, what is the angular speed? So that means that angular speed is equal to omega. Angular speed omega equal to 2 pi f, or it will be equal to 2 pi f is equal to 1 over t. Okay, tempo period. So from here, it will be equal to 2 pi over, okay, 1 revolution, how much? Okay, 1 revolution equal to 60 seconds. Okay, so 60 seconds, that means that angular, okay, second, yeah. So 2 pi in 60 seconds. So that means that it will be equal to 2 times divided by 60. So that means that angular speed, let's see, the speed for the second hand of a clock. So 2 pi in 60 seconds. So that means that we get that it will be 0.1047. How much? Radian per second. Okay. Next, question number 2. An object moves in a circular path of radius r with constant speed v. Prove that it is moving with an acceleration v squared over r and acting on the center of the circular path. Okay, so that means that this one, okay, we need to write more. So I share the screen to the Microsoft Words. Okay, let me take out my pen. Okay, for question number 2. Let's say if there is a circle. Let's say this is the circle where the center, this will be the center. Let's say this is the center. When it moves from a point to another point. Okay. Okay, better I use a line. From here, to here. Okay. So that means that what will be the distance? Okay. So from here, this, as we know that there will be a velocity which always 90, let's say for this one. Okay, at this point, okay, we choose this point. So this one will be the V. And if for this point, this one, okay, I choose and a point is more easiest for us to move. Let's say this one is exactly like that. So here we notice that the V will be in horizontal direction, right? So what we need to do, if I extend the line until they meet each other, okay, that means that this distance, okay, this distance will be, what is the distance? Distance travel. So V equal to S over T, right? S is equal to VT, right? Okay, so that means that this distance travel will be equal to omega with the times with the change of the time. Okay, that means that the angle, the distance, the angle, okay, So the angle, still remember, if that were for, what is that? For a portion like that, this is R, this is the delta, this is S. S equal to R delta. Delta, okay, is equal to, okay, sorry, delta, okay, yes, correct. Delta is equal to S over R. So this means R delta, okay. So this means one of the concept. So from here, this one, okay, we can set that if we combine like that, this will be the V, right? So the change of the V, this point from this point, okay, it will be the omega times with delta T. Okay, why? Because if I use the true line, like that, where I have another line, this will be the resultant. So from here, what are their relationship? This will be V, this also as V, right? Where this will get omega times with the change of time. So at the end, this will be change of the angular speed. Okay, so now omega, okay, we look at this again. S is equal to R delta, as we know. Okay, where this omega, like this, right? Omega will be equal to change of the angle over change of the time. Change of the angle over change of the time. That means that change of the delta will be equal to omega times with delta T. Okay, so this means it can be S over R. This one, the distance angle. Okay, now from the vector diagram, delta V from this point to this point, change of the speed is equal to V times with omega delta T. Omega delta T. So therefore, acceleration that's moved from this point, the acceleration from this point to this point, okay, that is the A. Acceleration is equal to delta V over delta T. Change of the velocity over change of the time. Linear, it will be equal to the V omega delta T over delta T, because V change of the, okay, change of the linear speed is equal to the V because constant, right? Okay, times with the omega times with delta T. So this means that the delta T can be cancel each other. Okay, this means that it will equal to V omega, where A is equal to V. Another one, omega is equal to, what is that? V is equal to, if R times omega is equal to V, right? Okay, so this means that omega is equal to V over R. So this replaces the omega with V over R, at the end, acceleration is equal to v squared over r. Okay, this is how we prove that the A is equal to v squared over r. Okay, so from here, if delta t is equal to 0 at 0 second, the direction of the delta v is at right angle with the initial v. Okay, so that means that no matter how, what we get this from the, okay, this one, the omega change of the omega, the change of the angular velocity. If there is a change of the angular velocity, that means that this will be always 90 degrees. Okay. It's my method. Which one? Casavatini. Casavatini.
Yes,
Yeah.
sir.
Yeah.
I already sent my answer script to your chat. Maybe later so can check it for me, lo.
Okay. So okay, so you send to Telegram, is it?
Yes.
Let me see. Okay. Okay. Stop for a while ya. Baru saya nampak sesuatu. That means that no matter how, okay, the change of the velocity, the change of the angular velocity will always direct to the center. This one from here to here, that means that it will be direct. This we get, it will be direct to the center. So if there is a change of the angular velocity, the acceleration is always direct to the center. This one, it forms that the angle, what's that? The centripetal acceleration. Okay. So now we go back. We go to the move forward to the question number 3. Question number 3: an object on the equator move in uniform circular motion due to the Earth's rotation. what is the angular speed of the object? Ladies and gentlemen, angular speed. This one, they have some space here, so we solve it here. Okay. One, angular speed omega is equal to 2 pi over t. That means that 2 pi over, okay, an object on the equator move in uniform circular motion due to the Earth's rotation. Okay, what is its angular speed? So this means that an object move in a uniform circular motion due to Earth's rotation. This means that, okay, around the Earth. So if the object around the Earth, that means that Earth, due to the Earth's rotation, right? Earth rotate in one rotation. One rotation equal to how much? 1 day. 1 day equal to 24 hours. So this means the period is 24 hours. We convert to second. 1 hour with 60 minutes. 60 minutes, each minute with what? 60 seconds. So at the end, how much is it? We get that it will be 7.3 times 10 the power negative 5. Okay, so that means that from here, the answer, no need to write the radian. So that means that the angular speed is s negative 1. I think just now, okay, there is one question. Okay, for the question number 1, okay, I give you, I accidentally write the radian per second. So cancel the radian for question number 1, angular speed. Just second, per second only. 2, what is the centripetal acceleration? Centripetal acceleration, we use the formula A equal to V squared over R. What is the speed? The speed will be equal to, okay, if R, V squared, V is equal to, what is that? V is equal to R omega, right? Okay, omega equal to RV. Let me check. Okay, V is equal to R omega. That means that replace in, we get that R squared it will be R omega squared. The radius of the Earth is 6.37 times 10 the power 6. This is a constant. Okay, times with the omega is 7.3 times 10 the power negative 5. Divide by the radius. R omega square. No need divide anymore. So this will be the square. So at the end, it will be equal to 0.0339 ms negative 2. So this is the, okay, acceleration. What is the acceleration? That is the centripetal acceleration. Okay, get it? Okay, now we move to the third worksheet. That is the centripetal, involved with the centripetal force. Okay, so we have 1, 1.1, 1.2, and 1.3. Whoa, sorry. Okay, so increase the size. Okay, for the centripetal force, Okay, now we look at here. A pendulum of mass 0.15 kg is suspended from a fixed point by a thread of fixed length. The bob is given, okay, the bob is given a push so that it's moved along a circular path of radius 1.9 meter in a horizontal plane at a steady speed. The bob takes 20 seconds to make 10 complete revolution, and calculate the speed of the bob, the centripetal force, and see what provides the centripetal force of the bob. So from here, okay, we use the, okay, let's move to the words file. Okay, now for the question 1.1. A, velocity of the bob. We use the formula V equal to R omega, where it will be equal to R is equal to how much? Okay, R times with 2 pi. Okay, let me see what is the question about. Yeah, okay. It makes 10 complete revolution. We use 2 pi f. That means that R is equal to 1.9 times with